if we have the integral from a to b of k f of x dx, what do you think this is going to equal? K is a constant. What do you think I'm going to write? K on the outside. Always in calculus, pull your constants out. Always, always, always. It makes your life easier. And then if we have the integral from a to b of f of x plus or minus g of x, what do you think this is going to? What do you think I'm going to do with this? Split it, just like with derivatives, just like we did with the sigma. A to b of f of x dx plus the integral from a to b d of x dx. So really, it's the same rules that you use with derivatives and sigmas and everything else. It's just, This is nothing new right here. Absolutely nothing new. From the derivatives, you're used to the sum and difference rule. This is really the same thing. It's the sum and difference rule, but it's for intervals. Yeah, it should be plus or minus. Yeah. Sorry. Go good? As of right now, we can't do too terribly much with this, but if I give you an integral from 1 to 3 of negative x cubed plus 4x minus 3 dx, I want you to evaluate it. You don't know how to do this yet. But I can tell you the integral from 1 to 3 of x cubed dx, oh no, it's x squared. My bad. Equals, dx equals 26 over 3. The integral from 1 to 3 of x dx should be 4. And the integral from 1 to 3 dx should be 2. Yeah, 2. So I give you that bit of information. What this means is, well, each of these are independent. The integral of x squared by itself from 1 to 3 is 26 over 3. The integral of x dx from 1 to 3 is going to be 4. And the integral of just 1, basically 1 dx, right? But the constant we don't ever write, from 1 to 3 of dx is 2. So I give you the values. So you're going to use the rules to rewrite this so you can use these to get your answer. So here we go. So I see pluses and minuses. What's the first thing you think of? Split it. So I'm going to do the integral from 1 to 3. I'm going to write negative x squared, but where can I put the negative? Out in front, x squared dx. Plus, I'm going to do another integral from 1 to 3 of 4x, but where does the 4 go? In front of x dx minus, well, I'm going to put my 3 in front again, from 1 to 3 dx. Huh? Where? Oh, okay, yeah, this is a 2. That's what you're asking? The 3 is a constant, I'll pull it out. Okay, so now I have a negative, I wonder what this equals. So, well, this part's 26 over 3, here's my negative, so I have negative 26 over 3 plus 4 times what? 4 times 4 minus 3 times what? And then from there you just throw it in the calculator, right? Don't miss a question because of arithmetic, just throw it in the calculator. What'd you get? So this equals 4/3. It's just a way to practice the rules. Now, we're going to integrate from 0 to 5 f of x dx, and f of x equals negative 2x plus 7 when x is less than or equal to 3, and 4 when x is greater than 3. So we're going to integrate this. So what does that actually mean? We're going to split it for sure because it's a piecewise function, but what does the integral mean? What are we actually trying to find? What is the meaning of the integral right now? We're using geometry to find what? Area. So we want to know the area of this piecewise function from where to where? 0 to 5. From 0 to 5. So we need to graph this piecewise function to see what type of geometric shapes we're going to have, right? Okay. So we need to use some Algebra 1 skills. This is scary. Algebra 1 skills. Why would you plug this in? This is super easy to graph. We're going to go from 0 to 5. We're going to start on the top part because 0 is less than, so we're using the top part. What is my y-intercept? 7. What is my slope? Negative 2. All right, so here is 7. And we have a negative slope coming down. And it is going to be an open or closed dot. Closed dot. What is this value right here at that closed dot? It's 4. How did you figure that out? It's not 4. It's not 4. We know that this is 3, so this has to be 1, right? Because we plugged 3 in. 3 times negative 2 is negative 6. Plus 7 gives me 1. Good job. Now, at 3, we're going to go up to what? What number? 4. Is it going to be an open or closed dot? Open, and we're going to go, what does 4 actually look like? Straight line, what type? Vertical or horizontal? Horizontal. So we're going all the way out to 5. So what we're looking for is this area. How would you find this area? Trapezoid and a rectangle. What is the height of my trapezoid? 3. What are the bases of my trapezoid? 1 and 7. Okay, so we know that we're going to have to do 1/2 of 1 plus 7 times 3 plus, so that's my trapezoid, right? So what is my length here? 2. And here? So this becomes 2 times 4. Yes? So this is 8, 24, 12 plus 8, 20. So this integral right here will equal 20. Like geometry all coming back, right? The key is graph. You got to get the graph right. So you guys got to get that. All right, trapezoid rule. Would you agree the trapezoids that we have been finding, we can say the area, I can represent this as f of x to the I minus 1 plus f of x sub I divided by 2 delta x. Or delta x is b minus a divided by n, right? I'm going to write that. B minus a divided by n. Would you agree that's basically how we're finding the area of these trapezoids? Endpoint, this endpoint minus this endpoint, blah, blah, blah. N is going to be our number of trapezoids, blah, 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 right? All right. If I do, notice I'm starting over here, right? If I want to do the sum as I equals 1 trapezoid to n trapezoids of f of x sub I minus 1 plus f of x sub I divided by 2 b minus a over n. Yes? Would you agree with this statement? I can pull this out because that's a constant. Can I pull 1/2 out because that's a constant? Do y'all agree with that? So I could rewrite this as b minus a over 2n. With my sigma equaling 1 to n now of f. Do y'all agree with this statement so far? Well, now we're just going to write it a little bit out to see if we see a pattern. So we're going to have our b minus a over 2n times, let's see, if I start at 1 here, what does this become? This first one. So I'm going to do f of x sub 0 plus, and I'll put 1 here, I get f of x sub 1. Now we're going to go to the next term. We're going to go to 2. What does this become? So f of x sub 1. If I put 2 here, this becomes? Now let's do 3, just because. If I put 3 here, what do I get? And if I put 3 here, I get? And we keep doing this all the way out to, I'm going to do f of x sub I minus 2 plus f of x sub I minus 1 plus, now if I just do n, yes, I'm going to do f of x sub I minus 1 plus f of x sub n. So I drew this out so y'all can see a pattern. What does this turn into? Can you combine like terms? Okay. Is there another like term to f of x sub 0? No. So ultimately I'm going to get b minus a over 2n times f of x sub 0 plus what? 2f of x sub 1. We're not done yet. Plus 2, plus dot dot dot, plus what? 2 f of x sub I minus 1. So the next to the last term, plus what? What's our very last term? Is there a 2 in front of this f of x sub n? No. That is your trapezoid rule. That is your trapezoid rule. Basically, you're just going to evaluate at the beginning, at the end individually. Every interval, you're going to multiply by 2. And then your delta x, you're just going to divide it by 2. That is your trapezoid rule. That is essentially what y'all were doing on y'all's. When you're adding those, when you're adding the triangles to your rectangles. All right, y'all got the rule down? This is the trapezoid rule. You'll actually see it like, you won't see this middle term, this term right here. They just stop at f of 2 times f of x plus 1 plus dot dot dot, and they jump to this. Because the important part is the end part, and then the middle part, you know, everything in the middle you're multiplying by 2. The ends are by themselves, everything in the middle multiply by 2. And then you're going to take your delta x, you're going to slap a 2 in the denominator, and you're good. Ready to do another approximation? No? I'll be nice to y'all. Man, we did not get through this in 3 days. These are slow. You don't know what you're doing. Okay. Let's do a nice easy one. Y'all ready? Ready? I want to approximate the area from 0 to pi of sine, oh I know, right? Sine theta d theta. And I want 4 trapezoids. Okay, so right off the bat, let's do the same thing. What is my delta x? What is it? Pi over 4. If I'm doing the trapezoid, what do I need to put in the denominator? So I'm going to have pi over 8. You all agree? And I'm going to start at 0, and my delta x is pi over 4. So I'm going to do sine of 0 plus 2 times sine of pi over 4 plus 2 of sine of, let's see, pi over 4, that gives me 2 pi over 3 pi over 4. What am I doing? I'm off somewhere. 0 plus pi over 4, pi over, oh, yeah. Give me, no, pi over 4 is 45 degrees, so 0, 45, should be 90. Pi over 2 plus 2 sine of 3 pi over 4 plus, oh yeah, we're counting it by 1. 0 pi, 1 pi, 2 pi, 2 pi over 4. I reduced it. 3 pi over 4 and 4 pi over 4, so I don't need a 2 there. We're counting it by 1. Confusing myself with just simply reducing my fractions. So there's my trapezoid rule. Now, see if you remember the unit circle. No, thank you. What is sine of 0? Put the calculator down. 1. So I have pi over 8. Sine of 0? Sine of 0 is 0 plus 2. What is sine of pi over 4? No. Square root of 2 over 2. Thank you, Philip. 2. What is sine of pi over 2? 1. What is sine of 3 pi over 4? Square root of 2 over 2. It's the y value, so it's still positive even though we're in quadrant 2, because the y is above. What is sine of 0? Yeah, sine of pi. Same thing. It's going to give you the same value. So now, I have pi over 8 times, well, let's see, I've got 2 square root of 2 plus 2. Yes? Let's simplify. Now I have pi times the square root of 2 plus 1 over 4. There's your answer. Did everybody understand what I did when I canceled here? I basically act like I factored out a GCF of 2, and then 2, 8, 4, and then 2. I just did it that way. I didn't add the extra step. And if you want a decimal approximation, throw that in the calculator. No, thank you. We have 1 minute till the bell. Huh? Now you can use the calculator to throw that in to get a decimal approximation. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.